Hi, this is Sparky Pete in Liverpool in my electrical science laboratory, which also doubles as my mum's garage. And I'm going to take you through the safe isolation procedure. Now, in reality, before we carry out the safe isolation, there could be a process of client consultation, tell someone you're going to knock the juice off. There might be a permit to work system to go through and complete. But here we can just go straight to the safe isolation. Now, it's a 4-stage procedure, 4 steps, and it's going to involve 10 tests. And the first step is to locate and secure the means of isolation. Now, as you can see there, I've got the board locked off with one of the devices from this safe isolation kit over here. Now, in that kit, there's a device for pretty much any kind of isolator or switch or circuit breaker that's out there. So step 1, locate and secure the means of isolation. Here it's straightforward. In practice, you might have to, say if it's in a school, for example, liaise with the caretaker to find the board. I mean, that could be a job in itself, but like I say, here it's straightforward. So locate and secure the means of isolation. Step 2 is to test our tester. Now what we've got here is a voltage indicator. It's not a multimeter. We want something that's clear and straightforward. Doesn't require batteries and only does one job. The first electrician I worked with had a lamp or a bulb with wires soldered onto it. We've come quite a long way since then. I'm going to go over to the proven unit. There we go. All of the lights come on. I'm also taking note that the low battery indicator is staying off on the proven unit. And I'm remarking on that because I've just had to change the batteries on that this morning. So there we go. Step 2, test your tester. Step 3 is to do the relevant tests on the circuit or board to be worked on. And that's handed it. Someone's taken the screws out already. Now what I say here if I'm taking a class is to say, have a method. You know, in reality, you don't want to miss any tests out. And if you're doing this as part of an assessment, you want to clearly demonstrate to the assessor that you know what you're doing. So what I would suggest is start on the earth. And from the earth, go to L1, L2, L3, and your neutral. Stay in your neutral, go to L1, L2, L3, and then L1 to L2, L2 to L3, and L1 to L3. So there we go. We're working on the load side of the board. Now in reality, the feed side of the board could remain live. Now that's an electricity at work regulations issue that. And basically there, if it was possible to isolate the supply to the board, we'd do that if we possibly could. But here, because there's no other way, or there could be no other way in reality, well, we're talking about on or near live conductors. So we're still near live conductors, but the only way we could do this, if we can't isolate the supply to the board, is what I've done there. Anyway, so that is step 3, test the circuit to be worked on. Now, when I'm taking a class, I normally say, so there we go, it's safe to carry out work. And I'm hoping that somebody's been listening and say, no, it isn't, because we've got step 4 to carry out, which is to test our tester. I'm just going to my proven unit again. The tester's still working. Now, the reason why we do that is because up to that point, those tests that we did mean one of 2 things. It means either that the circuit is dead or the tester is dead. And one thing I didn't say is, obviously, when I was carrying out the tests, I was looking at the lights to make sure none of the lights came on. Anyway, so there we go. So step 4, test your tester. And now we can say that circuit is safely isolated, or the board safely isolated and safe to work on. Any constructive criticism or any remarks welcome, because nobody knows everything and there's always more to say.